do this part. Good breakfast? What did you get? Just bread. Oh.
Me too, so I buy bacon.
No. Did you not want to put your bacon on your bread?
No. One bacon, one bread.
Separate? Not together? I think it would be nicer together. You know, bread, butter, bacon, mayonnaise, yeah.
It's difficult.
Yeah.
Some chips.
No, I don't.
Yes, chips,
Breakfast,
yeah.
I should put my bacon in my bread.
Yeah.
So no. Actually cut my breakfast.
Oh, no knife.
No knife.
Oh. You could tear it.
You can eat the whole thing.
You can wrap the bacon around the bread.
Eat. No.
Wrap it around.
No.
Make it sushi.
The bacon.
Exactly.
The
Bacon bread sushi.
Bacon bread. The bacon. Bacon and here have meat. Bacon in China no meat.
Bacon in China has no meat.
It doesn't taste like meat.
After this class, we can go to canteen and eat for free.
Really?
Aha.
What is the party?
Yeah.
What
How
is
much
today?
you want?
Today?
What is today?
Yes.
Then we're gonna sing.
No.
Yes, please.
Yes, no, it's
The best I can offer is if all the engineers sing together.
You sing with us?
Is there any song we all know in English? Like
ABC.
Welcome Gangnam Style?
Then we can next to go minus.
Yeah, we need a math song, don't we? Is there any song we all know in English? Probably
Let it
like
go.
Happy Birthday or something. Let it go.
There you go.
Yeah. And here is Let It Go by the Engineers.
You gotta get a sarcastic at us.
Best part.
We'll get kicked out of the canteen. Oh dear.
There you go.
What else?
ABC.
No.
Yeah, everybody knows this song, yeah? Any Christmas songs? That's right, yes.
It's a jingle.
It's a jingle,
You
yeah.
should do it.
Yes, also this one? But do you know any words?
Jingle bell,
Jingle
And that's it. We'll have to think about this if we do something. Yeah, no, actually, Let It Go might be good actually to do. Alright, so the last probability question here. A small cafe sells newspapers in the morning when somebody buys tea or coffee. So you could buy tea or coffee and then you could buy a newspaper or not buy a newspaper. The owner expects 45% of people to buy a newspaper. Okay, so what's happening here is you go into the shop and you can buy a newspaper or you can not buy a newspaper. If the customer, oh yeah, and here this is 0.45, and then this one here is 0.55. Okay. Now, if a customer buys a newspaper, the probability that they'll buy coffee is 0.65. If a customer does not buy a newspaper, the probability that they buy tea is 0.4. So I guess everybody buys tea or coffee. So you could have tea or coffee, then tea or coffee. So if they buy a newspaper, then it's 0.65 probability that they'll buy coffee, and then here will be 3.5. And if they don't buy a newspaper, then this is 0.4 and this is 0.6. So this is the probability tree. Is that okay? Did you have the same? Good job. You didn't. What was wrong, KJ?
Just
So wrong. Couldn't be more wrong. Yeah.
So
All right.
Up and down.
Hmm?
Mine is something.
what is the probability of a customer buying a newspaper and a tea? So probability, I'll split this in half. Probability of newspaper and a tea. That would equal 0.45 multiply 0.35, which equals, I do, got it today, 0.1575. C. Yeah, let's add in some colour. For what?
This is making me hungry.
Coffee.
What is the probability of a
Not
customer?
eat anything.
Yeah, so part C is the probability that they'll buy coffee. So that equals, let's zoom out a bit. That would be 0.45 times 0.65 plus 0.55 times 0.6. Yep. Let's have a look. 0.45 times 0.65 plus 0.55 times 0.6. What did you get, Taken?
0.6225.
Correct.
Why did you add it?
The reason here, KJ, is they could buy newspaper and coffee or no newspaper and coffee. You add the different branches.
Yeah.
What if they say something like the probability of buying a newspaper and coffee and tea?
Impossible. I know this question here, the customer always buys coffee or tea, but they never buy both. So maybe this coffee shop is having some special offer that when you buy a newspaper, you can then buy a coffee or tea
Like
for half price
Like,
or for
you
free or
know,
something.
in some shops, if you buy a drink or something.
Yeah, you get something with it. So, so maybe the shop is saying if you buy a newspaper, then you can buy a tea or coffee for half price.
Would you like to drink tea and coffee together?
Yeah.
Right?
Yeah. I'd say that's what's happening here,
Have you
KJ.
tried milk and sauna?
Damn.
Milk and 7-Up.
Yeah.
We can set it up.
What is that?
I'm not even going to respond to that. It's so ridiculous.
No, it's not.
It's ridiculous. Ridiculous.
What's the taste?
No,
You
don't
so many
encourage him. This is ridiculous. Milk and 7-Up. Ridiculous. Alright. D. Given that the customer buys coffee, what is the probability that he does not buy a newspaper? Okay, so for this one here, we should make a table. So given that the customer buys coffee, so our choices are, let me just make this here. We can buy coffee or not buy coffee, i.e. buy tea.
What's the question says?
Buy newspaper, I'll tell you now, and not buy newspaper. So for this one here, Fahad, they said, you know that they buy coffee. Given that they bought coffee, what is the probability that he does not buy a newspaper?
What's the probability of the customer buying coffee? What? Oh, okay, that's the question.
Yeah. So let's fill this table out. Coffee and newspaper. Well, actually, I see we have newspaper and tea already, so that's 0.1575. Okay. Do we have anything else? No. Do we have anything else?
Newspaper and tea with
Let's do coffee and newspaper. That works out to be 0.1575.
the same.
Just by coincidence, I think. Actually, that's a good question. Yeah. Newspaper and tea, 0.45, 0.35. Coffee. Oh, sorry, maybe I typed it in wrong.
Yeah.
Newspaper and coffee. No, it's not the same. Thank you, Karar. It's 0.2925. Coffee and no newspaper. Okay, 0.33. And what should the total here be? Should be 1, shouldn't it? No newspaper and tea. 0.22. Okay. What do we know? We know that they bought coffee. So we're only here. And what else do we know? We want the probability that they buy a newspaper. So we care about this one. So it looks like the answer will be probability that they...
Isn't by a newspaper.
Yeah. Oh, sorry. You're right. Thank you, Karar. Well, Karar, you're actually listening today. Probability that he does not buy a newspaper. So that's probability of no newspaper if, what's that? If he bought a coffee, isn't it? Yeah. So what would this equal? What fraction is this?
0.33
Yeah. 3, 3.
or 0.2925.
0.2925
plus
plus 0.33, which I believe is 0.625, is it? Maybe not, sorry.
No.
No, what am I talking about? 2925. It is.
0.53.
No, it is 0.6225.
No.
The bottom, I mean.
Yes, obviously.
Wow. So it's about half. 0.53. Okay. Now, last part here. 85 customers visit the cafe. How many of them will buy tea? So we should work out the probability of buying tea. You can actually see it up. Did we calculate it? Now there's a quick way you can do this. Probability of buying tea is 1 minus the probability of buying coffee, because you have to buy coffee or tea. So if 60% buy tea, how many buy coffee? 40%, and vice versa. How many people buy coffee? What percent? It's 62%. Yeah, so 0.6625. So this would equal, yeah, it would equal 0.3375, which would equal 33.75%. So if we have 85 customers, about 33% of them will buy tea. So that would work out to be,
It's 6225. Could you go?
is it 6225?
Yeah.
Yeah.
Okay.
The whole thing, you know.
So here. Oh,
Yes, it's 0.
Okay.
3775. So that's 27% of that.
I don't think it will change too. Oh, it's still 53% here.
Yeah.
So this is still 53. Sorry, it's just this one here, is it?
Mm-hmm.
377. Sorry, so this 3 should be a 7. So this here should be a 7. Yeah, okay. So about 37% will buy the tea. So of the 85 customers, about 32 will buy tea.
That's by coffee.
No, tea.
Others.
And the others will buy coffee, yeah. Yeah. Because 38% of 85 is about 32. You know, it's about 38%. It's not exact. It's actually 32.08, so it's about 32. Okay? Yeah. So that's the probability. So you can see that. Let me stop this.